This video is on conservation of charge and charging. This is part 2 of your notes. The essential question is still, how do objects end up with an unbalanced sigma charge or total charge? In the previous video that I made on this topic, we covered polarization and friction charging. In this video, we are focusing on the notes for contact charging, grounding, and induction. If you are missing these two notes, you'll need to go back to the previous video. So the last slide of the previous video was this electrostatic series. This is the order with which objects will either give or receive, insulators will either give or receive electrons if they are rubbed together. So I noticed that some folks didn't write in these materials, and it is helpful to have them written in to your notes so that you can refer to that later. I don't think it's super important to include acetate and ebonite, since those are probably not ones that you're familiar with. I'm not familiar with it. But these other ones are very common materials that we all know. Basically, if you have a material like rubber, it is more likely to take the electrons if it's rubbed. It's not more likely, it will take the electrons from glass if glass and rubber are rubbed together. If plastic and fur are rubbed together, like I did in that demo in class, then the fur will give those electrons to the plastic, making the plastic negative and the fur becomes positive. That's what this electrostatic series shows us. So these are new notes. The first form of charging that I'm going to talk about in this video is contact charging. Now, we were talking before about insulators. Now, if two conductors that have unequal total charge are brought into contact, the electrons will move until both of those conductors have the same total charge. So here's what this might look like. You have two objects. I'd like for you to draw in 9 plus signs, kind of in a nice orderly fashion. Those are your protons. And then you'll show that there are 3 electrons. Now, those, if we have, I'm going to go ahead and use my notes here. Here's our 9 protons and our 3 electrons. Electrons have a negative charge, so that's -3. Then we are left with +6. Simple math problem there. +6 coulombs of charge. And over here, we have 9 protons, and we have 1, 2, 3, 4, 5, 6, 7 electrons. You feel free to write that out down below. 9 minus 7 equals +2. So both of these objects are positively charged. Now, if they touch, then those electrons are free to move. And here's what that would look like. When they touch, the electrons will move from the one that is less positive, because there's more of those electrons. It's going to even out so that they both have the same number of electrons and protons. In this case, 2 of these electrons moved from this green one to the blue one. So that then they had 9 and -5 equals +4. 9 minus 5 equals +4. So now by coming into contact, they balanced each other out. It doesn't mean that they both became neutral. It means they both ended up with the same total charge. That's contact charging. Grounding. Grounding is connected to contact charging, where you have 2 objects that come into contact, and one of those is connected to the ground. So whenever we are plugging things into the wall, you have this grounding wire that goes from the house down, and it's drilled into the ground. Why do we do this? Well, the Earth is one giant neutral object. And so when you have an unbalanced charge in the house, you want to ground that so that let's say that it's negative, those electrons are able to flow into the ground and it neutralizes. And we don't end up building up static charge in the house, which would be obviously incredibly dangerous if our house was constantly a little bit charged, right? And the last one that I want to talk about is induction charging. So, induction charging, it feels a little bit complex, but it is a combination of polarization and grounding. And it's how you make a conductor unbalanced. So, it's how you give an unbalanced charge to a conductor. It's kind of easy to give an unbalanced charge to an insulator. You can just rub it and the electrons don't want to go anywhere. But with a conductor, what you have to do is you have to trick those electrons. All right, so let's talk about what that is. So we start with a neutral conductor. And when we say neutral, we know that it means that we have the same number of protons and electrons. So I'm going to draw in 4 protons in there and pair that with 4 electrons. 3, 4. When we can bring a charged object near, not touching, but just near. And what happens is that, so if this is a negatively charged pole that I'm drawing near to this conductive object, the electrons will be repelled from the pole. So the electrons want to move as far away from this negatively charged object as possible. One thing I don't like about how this drawing is drawn is that the protons also seem to move closer. So I would like for you to draw these protons as a nice orderly 4 of them staying in their original spots because protons don't move. Okay, so here's where the grounding comes in. We attach a wire to be able to ground the conductor. This allows those electrons that were repelled by this pole over here. It allows those electrons somewhere else to go. And so those electrons can travel through the wire and into the ground. Sometimes this is us touching an object and we are the connection. We are the connector. So when you touch a doorknob and you get zapped, you are that ground conductor where the electrons can flow through your hand and into the ground through you. Because remember, the ground is electrically neutral, so those electrons can travel through there. Remember, it can go the other way as well. If this was a positive object, then we could give electrons over here. All right, then we take away the ground wire. So now those electrons are hanging out in the ground, but they aren't able to get back up to those protons over there. And remember, we're drawing our protons as just, filling up that space, nice orderly way. They're not moving toward those electrons, right? I don't like these pictures there. And now when we remove that pole, we have our unbalanced charge in our conductor. It's electrically positive, and it can't become negative again, I guess, unless somebody touches it again, and then it could go the other way. That is induction charging. So that was the last bit of that, of those different methods. Now what I would like for you to do, if I can figure out how to clear my screen. There we go. So now you're going to revisit the essential question, how do objects end up with an unbalanced total charge, and give a general answer that encompasses all of the notes that you have from the previous 2 videos. If you don't have space to do that right here because you wrote there for your previous one, you took up all the space, just go ahead and write it on the bottom of the page right over there and circle it. That would be great. All right.